So, at this stage, we normally try to make sure that everybody is, as it were, on the same page of the manual. Because we often find for our courses that people do have different backgrounds, different levels of experience of the various bits of technology. The assumptions for this course are that you are already database administrators, that you are familiar with the 11G and 12c database and instance architecture. And the purpose of the review here is to make sure that you really are. What you have to be aware of is the memory structures involved in a single instance database. You should all know at this point what the instance is. The critical memory structures. Remember, 3 memory structures you must have: shared pool, buffer cache default pool, log buffer. The optional structures: Java pool, streams pool, large pool. You need to be aware of the disk-based structures: control file, online log files, data files, temp files. We have to be aware of full understanding of the single instance architecture. We need to understand how sessions are established, the role of the listener for spawn and bequeath of server processes, how sessions actually get established, because it's a bit more complicated in a clustered environment. We also need full understanding of what happens when you execute SQL. How server processes locate blocks on disk, copy them into buffer cache. How, for a select statement, you then select rows, join rows, project columns, perform aggregations, and so on. We have to understand how we execute SQL. DML can change significantly in a clustered environment. Redo, undo, commit processing. There are some changes there. Specifically, each database instance will have its own thread of redo. Each database instance will have its own undo table space. Commit processing in concept doesn't change, but because you have degrees of parallelism, extra parallelism between instances, the instances must be communicating so that we know when a transaction is committed in one instance and is then going to be visible in the other. And lastly, we must understand instance recovery. What happens if an instance fails? Because that is one of the major reasons for using RAC. That if one instance fails, the database remains open on another instance. Okay, so that's our assumed knowledge. There's also a lot of assumed knowledge about system administration type functions, disk management, file system management, TCP/IP. But we realized a lot of people in the database world are not so familiar with some of those features nowadays, so we normally cover them in the body of the course as necessary. Last bit of theory before we get technical. You have to be absolutely clear why you are using RAC. You've got to be absolutely clear on that. You do not use RAC just because you can. You need to have a rock-solid reason for using it. I've listed on this slide some of the reasons that are often given for using RAC. And always remember, RAC, you need to be clear on why you're doing it. Consider, first off, scalability. Now, RAC is Oracle's flagship product for limitless scalability. You need to be clear on what that actually means and whether it actually works. Take an example here. One of the problems I had to deal with a while back, it was a cell phone environment, telephone systems, and it was the SMS aggregator. Now, the SMS aggregators, the volume of traffic, SMS traffic or text, whatever you call it, is astronomical in the modern world. Now, whenever you get some sort of dreadful, talent show television program or whatever, and all of a sudden, because Simon Cowell has voted off someone you liked in X Factor or something, whatever you call Dancing with the Stars, whatever it is, the SMS traffic shoots through the roof. Millions of SMSs get sent. And every one of those SMSs is making money. Make no mistake about that. And what we found with this particular database is we hit a brick wall with scalability. You know, in terms of transactions per hour, as the SMS traffic came in, you know, we could do 5,000 an hour, no problem. 10,000 an hour, no problem. Once it went over about 40,000 an hour, bang! We couldn't handle the SMSs. You know, you'd be sending the SMS to your Twitter account or whatever, and you'd get back the error message, poof, transaction failed, or whatever the message might be. Absolute disaster when that sort of thing happens. We investigated, and it turned out to be a problem with Rolux. The way the accounting was being done for tracking the SMSs, for charging various people's accounts, the accounting was hitting a Rolux problem. Rolux problem. That was the issue. Now, Oracle's standard answer to scalability, it was simply a brick wall. We couldn't get past more than so many transactions per hour. Oracle's answer to scalability, they were saying, go to RAC, go to RAC. It'll solve all your problems. I'm going to ask you a simple question now. I want you to chat in the results. Do you think that converting single instance on one machine opening the database, to converting, say, 2, 3, or 4 instances on 2, 3, or 4 machines opening the same database, would that have solved the scalability problem where we're hitting limits caused with Rolux and queues? I want you to chat in, please. A yes or no, or perhaps an I don't know. It's some sort of idea of how you think it would help, of whether you think it would help or not. We need some sort of idea. You must be absolutely clear on why you are using RAC. The reason you're here in this seminar is presumably because you're thinking of using it. Well, remember, RAC is costing you, Enterprise Edition, $47,000 per CPU core, plus another $23,000. It's a hugely expensive investment in software, in licenses, in hardware, in administration fees. Is it going to give me scalability in that problem? Yes, no, or I don't know.
We've got about 10 responses so far, John. So
okay.
We've got 32 with us. There's 2 more. So let's give it a minute. Folks, we'd really like to hear what you think. Yes or no, or maybe. Would RAC help solve the scalability issue that John presented?
We're hitting Rolux. The reason, by the way, was fairly clear. The application servers would send the transactions through from the SMS aggregator would send the data through to the application server, and the application servers would send it through to the database. And every now and then, a transaction would get stuck, and it wouldn't commit for perhaps a quarter of a second or so. And that was long enough to cause the queues in the application server to shoot up as the connection pool, the pooled connections got blocked for just a quarter of a second or whatever. And then if you've got any ideas, okay, let's go on then. Dave, what's the sort of aggregate opinion? Are we getting yeses or nos overall?
Yeah, we're getting more nos than we are yeses. We've got about 8 or 9 nos, a couple of possibles, and only a couple of yeses.
That's good. That's good. We're getting good level of experience here. The answer, of course, is I think RAC would actually have made it worse in that case, because the row locks might well have been between instances. I could have locked a row in one instance. You could be trying to lock it in another. That is probably even worse than having a contention problem within one instance. So you've got to be clear of that. Does RAC deliver scalability? Not in that case. Take another example. Maybe your AWO and StatsPack reports are telling you that the bottleneck in your system is DB file scattered read and DB file sequential read. This is a more subtle question, by the way. If your bottleneck is scattered read and sequential read, will going to RAC help? Yes or no? Why? Why not? We're hitting DB file scattered read, DB file sequential read wait events. And that's what's soaking up all our DB time.
Only got about 4 responses now. We're looking for a few more thoughts on this. There we go.
I promise not to laugh at you.
No, no laughing.
Oh.
This is a bit tougher question, John. We've got quite a few no's.
Okay, it's an interesting point, this. Will it help? And this is where you need to be understanding the complete environment. In principle, you might think first off that going to a rack will not solve problems of disk I/O, because your database in a rack cluster is on a shared disk. So if your disk I/O is already maxed out, how can adding extra instances help? If anything, surely it will make things worse, because there'll be even more read-write requests hitting the disks, which are already maxed out. In fact, it isn't quite like that, because multiple database instances in a rack means multiple buffer caches. You may well find that instead of having a single 50 gigabyte buffer cache, you've got 4 50 gigabyte buffer caches. So perhaps you're caching a whole lot more. Perhaps. So you might actually find that rack will reduce your disk I/O. There's another possibility. Each node in the cluster will have its own I/O channels. So maybe the disks themselves are not maxed out, but you're flooding the I/O channel to disk. In that case, go to a 4-node cluster, you've got 4 times the I/O channels. So potentially, you can increase your I/O by a factor of 4. But if it really is that the disks are maxed out, then rack ain't going to help at all. So what I'm trying to get you to think about are those first 2 examples. The whole environment has to scale. My first example, the application didn't scale. Contention was built into the design. Only solution, redesign the app. Disk I/O. If the disk can't scale, you'll get no benefit. The whole environment has to scale. The application, the disks, the CPU, everything. Rack is only part of it. You will only get scalability if the whole environment scales. Okay. Next reason for rack, fault tolerance. This is the headline usage. An instance fails, the database remains open in another instance. And Oracle calls that 100% uptime. But maybe not. When an instance fails, the entire cluster will freeze. Maybe only for a couple of seconds. So maybe people won't notice. But the entire cluster will freeze if an instance fails. Yeah, and they could fail for a number of reasons. Network card problem, so you lose access to the server. Yeah, there are any number of possible reasons. Instance fails, the whole cluster will freeze. Possibly nobody will notice. The sessions against that instance are broken. No question about that. They're broken. Active transactions will be lost. Sessions will have to be re-established. Okay, we can use transparent application failover to reconnect the sessions the users may not notice. You can use, in 12c, if you're really advanced in a really advanced environment, you can use application continuity, so your transactions can fail over. Maybe. So you do get fault tolerance, but your sessions are broken. Your transactions may well roll back. Is that fault tolerance 100% uptime or not? Well, Oracle says it is, though users might not agree. You have to consider what fault tolerance will rack really give you. Performance. Ooh, there's a good one. Let's try another quick poll. A yes or a no? Do you think rack will improve the performance of your application? Oh, Philip, I saw your comment. That's as good an answer as you can get. A definitely maybe.
You saw, John, we have a yes if parallel query is used.
Well done, whoever sent that in. Well done there. Basically, rack and performance is very dodgy indeed. It's very dodgy. When a customer asks us, say, can we know we want to convert to rack, and you say why, And the reason is performance. I get worried. What you need to bear in mind with performance is that most things to do with human beings, websites, a forms application, an Apex application, most things to do with people, RAC isn't going to help at all, because the work they're doing is typically sequential. You do this, you do this, you do this, you do this. Your user, the user is a single-threaded process. The session is connected to, dedicated server or through a connection pool, is a single-threaded process. There's not much reason why RAC is going to help, because your user's session is only ever against one instance. The exception, though, is parallel query and parallel DML. If you can use parallel query and parallel DML, then RAC may help performance, because you can get higher degrees of parallelism by distributing the work across the RAC. But I have to emphasize with this, with performance and parallel query and parallel DML, it is extremely difficult to tune. You need to have absolute clarity on how you're using things like partitioning, if you're using it, how you're using parallel execution. The communication between the instances is vital. The concept of the partition-wise join, which I'm sure some of you are familiar with, is critical to get performance out of a RAC. Historically, people used to say that RAC and data warehouse was a bad thing. I no longer believe that. I think RAC and data warehouse is a very good thing if the database is designed and the RAC is configured appropriately. So performance, that's a difficult one. That's a difficult one to say. Yes, maybe, depending on the environment. Cost, of course, is an issue. Cost, standard edition, RAC is a brilliant value for money solution. Low cost Intel servers, standard edition databases, RAC is a wonderful solution for delivering the scalability, the fault tolerance, and the performance within the limitations I've described. But when you come to Enterprise Edition, of course, well, cost is then different ball game entirely. So to conclude this discussion, before you even think of walking up to your first server, you must be absolutely clear on why you're using RAC. I've worked on RAC implementations that were disastrous, and they weren't disastrous because I was working on them. They were disastrous because the expectations were set incorrectly. Now, the problem we have here is that if a customer comes up to me and says, should I convert my database to RAC? I will say, yes, of course you should. Well, your next question should be why, and my answer is because I enjoy it. Well, that isn't good enough. You need to be absolutely clear on your business reasons for using RAC.